Hello students. So today we're gonna start with our next question, that is question number 32. Show that the function defined by f of x is equal to mod cos x is a continuous function. As I have said you can do this in two methods also. I am now showing for this the second method how we gonna do. Okay, so solution, what they have given, I am writing we have f of x is equal to mod cos x. So as our second method we are considering our composite, right? This is a composite function. First you have a cos, yes, trigonometric and a polynomial with mod. So how we do? First we write our, we separate two functions are there, so we are writing our two functions. So how we do? We write our two functions here. First is what? G of x I am taking, yes, g of x is equal to, g of x is what? Cos x, and h of x will be what? Mod x, right? Mod x 1 and 1 is your cos. Two terms you have here. So now we have to write the composite function. See, whenever you are writing the composite, you should make sure, you should understand in what function the other function is inside. Okay, like in your previous question it was cos of x square, means x square was inside cos, right? So we have taken g composition h of x, so that first h of x I should write inside part, then becomes the outer. Here also you see, here the outer part is mod and your inner part is cos. Yes, your cos is inner part and your outer is mod x. So first your inner part should come as your cos x, your outer should be your mod x. So you have to write your composition in such a way. So as you can see, your cos is inside your mod x. So your cos x is what? G, and your mod is of h of x I have taken. So how I'll write? I'll write as h composition g of x. H composition g of x. Why I have written? See, first which is the inside part, that you have to write the second term, so that while opening up we will get the same question. So here like this, how I write it? H of g of x. Composition we always write like this, h, your bracket, and g of x whatever. So here h, g of x is what? G of x we have taken as cos x. Yes, g of x we have taken as cos x. So I have got g of x as a cos x. Then the second part, it is how it is h of cos of x. Here how we are getting h of cos of x. H of cos of x, what we have? H of x is equal to what? Mod x. Yes. So h of cos of x, see here you see the left hand side, and this also h of cos of x is your mod x. So this both should be equal, right? So h of cos of x, when your h of x is mod x, then h of cos x will become what? Mod of cos x. So h composition g of x is equal to mod cos x. So after this what I have to write? Therefore composite functions are continuous functions, composite functions are continuous function. Next line you can write therefore f is a continuous function. Okay, as your trigonometry is also continuous, your polynomial is also continuous, therefore your composite of that, the interconnected term of that, that is composite function, is also continuous. So your next question, 34th, find all the points of discontinuity of f defined by f of x is equal to mod x minus mod x plus 1. So here they are asking you point of discontinuity. Discontinuity means what? Where it is not continuous. So here they are asking you to find the point of discontinuity of function. Function how they have given you? Mod x minus mod of x plus 1. So here you can see they have given you the function. Likewise the other previous functions, how they had given you the conditions, like which it was less than 0, less than 1, some points they had given you. Here they have not given you, which means you have to find out for that. Yes, for this you have to find that conditions, you have to form that function, and then you have to check whether they are continuous or they are not continuous for the particular points which we take. So here you see you have mod x minus mod of x plus 1. So whenever we start, first we try any equation to equate it to 0, right? So see it. So this is one equation, this is one equation. So both the equations are equate to 0. So what I'll get, that will be the two conditions. So first if I take, this will be your x is equal to 0, this also x plus 1 equal to 0. So I get x, this if it goes it becomes minus 1. So I'm getting 2 points. Yes, I am getting 2 points. One is x is equal to 0 and the other one x is equal to minus 1. So I am getting the 2 points. So if I draw my number line, okay, this is my number line. So this is my 0, this is my minus 1. 2 points I am getting. So considering this 2 points only, I have to form my equation. Like how? Now minus 1, first your x less than minus 1. Yes, x less than minus 1 points, x greater than 0 points, greater than or equal to points, and 1 here between greater than minus less than minus 1 and okay, one is x less than minus 1, second will be x greater than or equal to 0, and the other part will be lying between your minus 1 and 0 and here points. So we are getting, we'll get 3 condition. One will be less than, one will be greater and less than 0, and this will be your greater than 0. So considering that, first we'll see x less than minus 1 points. So at x less than minus 1, your f of x is what? Mod x minus mod of x plus 1. So for this we have to check, okay, less than minus 1 terms. So mod x, how I have said, mod x is a part of what? Plus and minus. So when it is less than means it lies between negative, right? So your mod x, how we write? Plus x and minus x. This will be your x greater than and this is your x less than. So for x less than minus 1 means our mod x will be what? Minus x. This also same, minus sign as it is, keeping minus sign, and this whole term will be what? Minus of x plus 1, minus of x plus, because this is mod, right? And this mod, when it is less than means this will be minus term. This minus is as it is, and this whole term will be minus of x plus 1. So you should make sure when you are making the terms, when you are grouping, when you are writing it. So now minus x, minus into minus is plus, and this is x plus 1. Minus x plus x get cancels and you'll get what? Plus 1. For a condition x less than minus 1, your output what you're getting? You're getting plus 1. Second condition, what I had said you, lying between minus 1 and 0, that is x less than equal to minus 1 and greater than 0. The points between these points, it will be x will be, this will be greater than 0 and less than equal to minus 1. So that condition. Again your f of x is what? General, mod x minus mod of x plus 1. So considering this, first term what they have said, it is less than or equal to minus 1. First term is less than or equal to minus 1. So here this will be what? Minus x. This is less than means your mod x becomes minus x. So that I have written minus x. Sign remains as it is, minus. Here they have said is greater than 0. Next term is it is greater than 0. So this will be positive only. So mod x will be what? X plus 1. It will be positive. So minus x, here again you are multiplying minus x, minus into plus is minus 1. Minus x becomes minus 2x, and this is minus 1. So if a condition x lying between minus 1 and 0, your condition output is what? Minus 2x minus 1. Third condition is what? X greater than or equal to 0. So a third condition at x greater than equal to 0, your f of x greater than equal to 0. So both the conditions will be positive, right? So mod x will be, it is greater than, mod x will be x minus sign, and this will mod x plus 1 will be x plus 1. So x minus 1. So plus x minus x get cancels and you will be having minus 1. So it is minus 1. So for a condition greater than or equal to 0, you have minus 1. So I got the function, I got the proper function how it is. So I am writing, so f of x is equal to, if x is less than minus 1, my condition is what? Plus 1, right? If x is less than minus 1, my condition is plus 1. If x is less than equal to, if x is less than equal to minus 1 and greater than greater than equal to minus 1 and less than 0, my output is what? Minus 2x minus 1. So if x lying between minus 1 and 0, my output will be minus 2x minus 1. And for x greater than equal to 0, for x greater than equal to 0, my output what I have got, it is minus 1. So you have formed the question. After forming, then you have to go for your regular base, there where we will check our continuity, whether it is continuous or no. So here you have got for two conditions, right? Minus 1 and 0. So you have to check first for equal to minus 1 and equal to 0. Please make your correction. Your first condition you take at x less than equal to minus 1. Yes, we take less than equal to minus 1, greater than equal to 0, and this will lies between greater than minus 1, less than 0. Okay. Your next condition is minus 1. It is just less than x less than 0. So x lies between minus 1 and 0. It is greater than minus 1 and less than 0. And third will be greater than equal to 0. This is less than equal to minus 1. This is just less than x, and this is greater than equal to 0. So here also condition, it is x less than minus 1 is 1, x greater than minus 1 and less than 0, it is minus 2x plus 1, and x greater than equal to 0, it is minus 1. Here it will be less than or equal to. So as same your case 1, first at x equal to minus 1 we will find. So first at f of minus 1, at f of minus 1, exactly what you will get? This is wrong. At f of minus 1 exactly it is what? It is 1. Okay. At f of minus 1 it is 1. Then next we have to find our LHL and RHL. LHL, limit f of x as x tends to minus 1 minus. Minus 1 minus means less than. So less than is our f of x is what? 1. So limit 1 as x tends to minus 1 is equal to 1. RHL, limit f of x as x tends to minus 1 plus means greater than. X greater than minus 1. X greater than minus 1 is what? Minus 2x minus 1. So f of x is minus 2x minus 1. Substituting your x as minus 1, so you get minus 2 into minus 1 minus 1. Minus into minus becomes plus. So plus 2 minus 1 is 1. So your at f of minus 1, your LHL, RHL are equal. So it is continuous at f is equal to minus 1. So f is continuous at x equal to minus 1. In the same way you have to check for at x equal to 0. I have written it, go through it. At the last you will get f is continuous at x equal to 0 too. At f of 0 you are getting minus 1, LHL also you will get minus 1, RHL also you will get minus 1. So three conditions are equal. So f is continuous at x equal to c. Therefore there is no point of discontinuity. For this question there is no point of discontinuity. Next one, this 21st, we have done it already, but in another way also I am showing you. Another way means the one which I had said you taking C minus LHL, RHL, you have to take it with accordingly as your H. Okay, taking your H as I have said you in trigonometric, because based on the marks you can solve it. If for 2 marks it is directly as I have showed you earlier, you can do it. If for 5 or 4 marks it is, then better you go for in this method. So first question only, sin x plus cos x, write your given, and at C also we are checking. So at C we get sin C and cos C. So we'll go for LHL and RHL. If both the equal and at this is also equal means 3 also equal means it is continuous. So first for LHL, limit f of x as x tends to C minus. Yeah, I have said you C minus means along with C there is some term. Like C minus it is not alone. So this will be like C minus h. When it is C minus h, as your h tends to 0, as your h is approaching to 0 means h is a very small number. Along with that we are taking h because h is a very small number. We can tell it is equal to like 0. It is like equal to, very near to 0, like 0.999, like that it is. So we take a C minus if it is means C minus h, and if it is C plus means we take x tends to C plus h, where your h will be tending to 0 itself. So in the same condition, limit x tends to C minus sin C plus cos C. So when you are writing it, you should write sin c minus h as your h tends to 0 plus cos c minus h. So now here you see you can apply the formula opening up sin c minus h is sin c cos h minus cos c sin h plus cos of c minus h is cos c cos h plus sin c sin h. This is your formula. Remember your formulas. You have studied this. Or else directly here only you can apply your, as h tends to 0 directly you can see here as your h tending to 0 you will get sin c, and or else you can open it up. Now substituting h as a 0, right? Substituting h as 0. Cos 0 is what? 1. So sin c into 1 will get sin c. Sin 0 is what? 0. So this term will be 0. Plus I am writing. Cos 0 is what? 1. So cos c into 1 is cos c. Here sin 0 will be 0. So you will be left with sin c plus cos c. Same way for RHL, here C plus means how it will be, x tend to C plus H, means it is when you are taking C plus or C minus, they are just not a single term. Along with that some term is coming, that is H, which is very near to 0, So every problem whichever I have showed you, just C minus and applying directly, you can do directly or you can go for this. But in trigonometry especially I am telling, just go this method only, because this is easy, and for further also in many textbook and all you get in this way itself. So sin of c plus h, cos of c plus h, I am writing the formulas and then substituting as h tends to 0. So you are getting LHL is equal to RHL is equal to f of c. So f is continuous. Remember the formulas. Thank you.